Assalamu alaikum students. Today I will explain you the our lab number 9, which is the interfacing of ultrasonic sensor with Arduino. Okay, so let's do that. First of all, let me launch Proteus and see what we can do with the Proteus in order to interface ultrasonic sensor. The first question would be whether that is possible to do it with Proteus or not. Yes, that is possible. Let me make a project with the name Ultrasonic and give it a path. Okay. Let's give it, let me name this folder with the name extra. Okay. Now create a schematic. We are not gonna create a PCB and finish this. First of all, I would like to tell you that we can take the schematic of ultrasonic sensor the way we did for Arduino. If you remember in our last lab, we downloaded the library, Proteus library for Arduino. Similarly, what we will do is that we will search ultrasonic sensor Arduino library for Proteus. Yes, we can also write Proteus. Okay. Now this first link is the engineering projects. We downloaded our Arduino library from the same website. If you click this, then you can download the library, download ultrasonic library for Proteus. If I click this, the download will start in obviously in 20 seconds. Okay, so I have already downloaded the library, and again I would like to tell you that I would like to tell you about the path where you are going to put this library, this downloaded library. Go to C, program data, lab center electronics, Proteus, library, and here you can copy paste those downloaded files. Okay, once you are done with that, now the first thing I would like to check is the library for ultrasonic. Okay, so this is the library for ultrasonic. Now students, remember this is just a layout of ultrasonic sensor. Okay, once this library is downloaded, I will show you one more file which we need to put in this schematic, which we have to put in this layout. Okay, so this is very important. This schematic won't work if you don't give it the right hex file that the developer of this library has made for this object. Okay, now if you unzip this, here you can see 3 files. For in the case of Arduino, there were 2 files, these 2 files. So these 2 files will go to the library of Proteus, and this one, this .hex file, will go to the module of this ultrasonic sensor. So if I double click this, I need to give it the path of this hex file. Go to the same folder where you have unzipped the library for Proteus and give this module the path of this hex file. Okay, so now this ultrasonic is ready to be used. Okay, let me drag this a little. Okay, so now we also need Arduino. uh, okay, let me get this one. This is Arduino, and we also need to have alphanumeric LCD. Here you go. This is the LCD where we would like to display the data of our ultrasonic sensor. So why this ultrasonic sensor is used? Ultrasonic sensor is basically used to find the distance. You can see these two transceivers. One is the transmitter, the other one is the receiver. Now one triggers acoustic signal, and the other one echoes that acoustic signal. Okay, so I will explain this to you in a while. One more thing we would like to bring in is a potentiometer. Okay, with this potentiometer we can replicate our object. Okay, we can replicate our object. We can simulate it in a way. For example, if we have kept a glass in front of that ultrasonic sensor, now this ultrasonic sensor will send a signal. That signal will transmit back, and the echo will detect that signal, and based on time, in how much time we have received that signal back from the glass, we can find the distance. Okay, and we have already studied that formula in our physics class. S is equal to Vt. That will give the overall distance. Okay, so I will explain that in a while. So this potentiometer will basically replicate that distance of the glass, whether we are moving that glass towards the ultrasonic sensor or we are moving that glass away from the ultrasonic sensor. Okay, now this for this ultrasonic sensor we need to give it some power and a ground as well. Okay, now if you see, we can change the value of this ultrasonic sensor. By this we can make an analogy that we are dragging that glass towards the ultrasonic sensor, or we are moving that glass away from the ultrasonic sensor. So I hope you got this point. So this is the setup for ultrasonic sensor. Okay, so before we start our programming, we would like to make our schematic. Okay, so let's connect this trigger pin with pin number 7, echo pin with pin number 6 of our Arduino. We can also connect this 5 volts with our Arduino. Even if you don't do that, this doesn't matter. Okay, this ultrasonic sensor will automatically detect 5 volts. So we are done with the connections of ultrasonic sensor. Now let's connect our LCD. Register select. I'm connecting it with register select with pin number pin number 12. Enable with excuse me, pin number 11. D4 with pin number 5, D5 with pin number 4, D6 with pin number 3, and D7 with pin number 2. So I guess we are done with the connections of LCD and ultrasonic as well. One connection missing is this the connection for read write, whether we are gonna write something on LCD or we are gonna read something from LCD. So since we always write some data or some command or some values on LCD, so I will connect it with the ground. If we have to read from the LCD, then I am supposed to connected with VCC, or what other thing we can do is that we can connect read write with some pin of Arduino in order to program it. How we can program it? If we would like to write something on LCD, we will give that pin 0, or and if we have to read something from LCD, we will make that pin high. Okay, so we are done with almost all the connections of this schematic of these two components, which are liquid crystal display and the ultrasonic sensor. Now let's program let's program for these two, for the interfacing of these two. Okay, now the first thing is, since we are using the liquid crystal LCD, so we will call its library liquid crystal .h. Now we can also define our trigger pin, which we have connected with pin number 7. We can also define our echo pin, which we have connected with pin number 6. Now once we start the programming for these two pins, we will just make use of the names instead of finding the numbers of the pins with which we have connected our ultrasonic sensor. Okay, now for the liquid crystal, let me define an object LCD, and this first one is for the register select. This is for the enable. We have connected register select with 12, enable with 11, and then 5, 4, 3 and 2. Okay, this 5 is for D4, 4 is for D5, 3 is for D6, and 2 is for D7. Okay, now we are done with this defining our pins and defining the pins of our LCD. Now we would like to define what is the mode of these pins. Now this trigger pin is going to be an output pin, because we are going to transmit the signal, and this echo pin is going to be an input pin, because on this pin we are going to detect our transmitted signal. Okay, now we can also define serial dot begin. This we do in order to see the data on our serial monitor. So if we would like to see the data on the serial monitor, we have to set the baud rate. So in this case we have set the baud rate to 9600, which is very common. Now LCD.begin is used for the initialization of LCD, whether our LCD is 16x2, 16x1, 16x4, 20x1, 20x2, whatever it is. So we are going to make use of this built-in mnemonic LCD.begin in order to initialize our LCD. So once we are done with this initial setup, now let's define our local variables. First of all, we would like to save the duration of the transmitted signal and the received signal. Besides this, we also would like to see the distance in centimeter and the distance in inches. So let's make use of these three variables. Now, first of all, I would like to, before we proceed further, I would like to explain the process, how this actually works. Okay. Now, if you have a look at this this diagram, Now this trigger pin works in a way that what we will do is initially we would like to low our pin. Okay. Uh, I hope I can edit this. Let me pause the video and see how I can edit this. Okay, so now I am able to edit this. On the trigger pin, if you notice, in order to send this acoustic signal, this is the acoustic signal. These are actually 8 pulses of 40 kilohertz frequency. Okay. In order to send this signal, the process is going to be we will send some low signal on our trigger pin and then a high of 10 microsecond, a high signal of 10 microsecond, and then a low signal. Okay, so that is how we are going to program our ultrasonic in order to transmit this acoustic signal from the trigger pin, from our ultrasonic sensor. Okay, so once we are done with this, we will place an object, or we will wait for the object, or we will wait for the acoustic signal to detect an object. Once it detects the object, there is going to be this acoustic signal is going to come back, and it will be detected by the echo signal. It will be detected by the echo pin. Now this is our reflected signal, okay, of the same frequency. It also contains 8 pulses. Now the only thing left is we need to see this delay. Okay, let me change the color. We would like to detect this delay. Okay, this delay. How much this delay is? When was this pulse sent, and when we received the first pulse of the reflected signal? Now this is, we can name it as the propagation delay. Now this one, once we measure this, and then we can do some calculation because we would like our data to be displayed in centimeters or in inches. And obviously one more thing I would like to explain is we also need to divide our signal, our value by 2. Why would we do that? Now let's assume, let me open this in Paint so that I can add it. Okay, now have a look at this. Now this is transmitting acoustic signal. Over here is the object. Now this is the reflected signal. Okay, yet we don't know what is the distance. Forget about this 10 centimeter. Okay, now this is a round trip. This signal goes here and then it comes back. We don't want this complete duration. We just want half of this. Okay, we just want this distance. Okay, I hope that is clear. So what we will do is that we will divide the received value by 2 in order to see in order to measure the distance between this ultrasonic sensor and the object. Okay, between the object and the ultrasonic sensor. Okay, now the speed of our sound signal is 340 meters per second. Now let's convert this 340 meters per second into centimeters. We can do that. We know there are 100 centimeters in a meter. Besides this, we are also converting the seconds into microseconds. So once we are, we would convert this seconds into microseconds, because the time is gonna be quite less. If we convert this, if we take the time in seconds, it will be, there will be a lot of decimal places involved in that value. So acoustic signal is very fast. Obviously not as fast as the speed of light, but still it covers 340 meters in 1 second. So we are expecting that our detected value is in time is gonna be somewhere in microseconds. So that is why we have converted our speed of sound in microseconds. Also, we have also converted our meters into centimeters. With that, you will come, the speed of sound is gonna be 0.034 centimeters per microsecond. Okay. Now, we can calculate the time. T is equal to S divided by V, or the main formula is S is equal to VT. Okay. Now, we don't know this distance yet. We will divide our distance, whatever the value we have received, we will divide it with 0.034. Okay. Now this will give us the time. Okay. Once we know the time, then we can make use of this formula. Okay. S is equal to T into 0.034 divided by 2. So that is how this we can calculate the distance. We don't know the distance, so we are interested in distance. So if we just make use of this formula, S is equal to T into 0.034 divided by 2. Okay. So if you just write down this in your code, we will receive the value of T, and then we can insert the value of T in our code, and this will give us the distance in centimeters. Okay. Now let's code it. Okay. First of all, we would like to transmit the acoustic signal. For that, let me write digital write. That is how we make our digital pin high or low. Now let's write trigger pin, which is pin number 7. We don't need to remember that anymore. First of all, let's make it low. For how much time? For some time. Somewhere in microseconds. Let's make it 2 microseconds. This value 2, 3, 4, this doesn't matter much, but the next value matters a lot. Digital write, or what I can do is that I can just copy paste this. And then one more time. Now I would like this trigger pin to remain high for 10 microseconds. If you remember that picture, we need to make it high for 10 microseconds. So we made it low, and then we made it high for 10 microseconds, and then again low for this much time. Okay. So once we are done with this, okay, then we can save our value, our received value, in the duration variable. Pulse in is the built-in mnemonic that will get the value from the echo pin if we keep it high. Okay. Now the value will, this pulse in will get the value from the echo pin, okay, and it will save that value in this duration. Now after this we need to do some formulation. Distance underscore centimeter is equal to duration, whatever the value we have received over here, duration divided by 2, duration divided by 2 into 0.0344 maybe. Okay, so this will give us the distance in centimeters. Our value is going to be saved in this variable. Now we know if you would like to convert this into inches, then what we can do is that we can divide distance underscore centimeter with 2.5400, basically 2.54. Okay, I can, this will give me a syntax error. Okay, so now we need to also write something that, for example, we also would like to define a range if our ultrasonic sensor is the maximum range of it is, for example, 800 centimeter. You know, there is a specification for every ultrasonic sensor. For example, its maximum range is up till 800 centimeter. Or if the object comes very close to the ultrasonic sensor, it is also very difficult for ultrasonic sensor to detect the accurate value. So there is a range, the working range of ultrasonic sensor as well. We can also put that range in our formulation. For example, if distance underscore centimeter is greater than and equal to 800, or distance underscore centimeter is less than or equal to 10, then what you do is that kindly print lcd.print out of range. Okay, and then once it is out of range, then you wait for half second and then again see whether the object is in range or not. Else what you do is that lcd dot set cursor, what we can do is that we can search Arduino LCD or liquid, let's write liquid crystal. Okay, this is the library we are using, right? We can go to this library, which is liquid crystal library, and then we can see these built-in functions. We can make use of these built-in functions. Otherwise we will have to code for this each and every function. So we should be aware of all these functions, because this will make our life easy. For example, if we have to set cursor, see, if you click on this, so this will tell you how to set the cursor, okay? Or this is the function set cursor, okay? So this will tell you how to set the cursor. The first one is the value of the column and the second one is the value of the row. If you would like to use this second row of the LCD, if you would like to make use of this second row of the LCD, then you can write 1 over here. Actually this is column. this is row. You can write 1 over here, and then you can set the column as well. So there are 16 columns in this LCD. Okay, so that is how you can make use of these built-in functions. So lcd.setCursor, for example, I would like to write from column number 3 and on the row 0. So the first one is actually row 0, and the second one is row number 1. After setting the cursor, I would like to print something which is this value, distance underscore centimeter. So let me write distance underscore centimeter. Now the value within this variable is going to be written on the LCD, not this thing, not distance underscore centimeter. It will write the value that this variable contains. Okay. Now, for example, if it is 10 centimeter, so 10 will be printed on the LCD, and in front of that 10, we can also print maybe with some space, or let's skip this space. We can write 10 centimeters, okay, or whatever the value comes in distance underscore centimeter. Okay, so after that, we can also write the value of distance underscore inches as well. How much it is in inches. So LCD dot set cursor. Let's write it on the next row, third column of the second row. Okay, for the second row we will write 1. LCD dot set cursor 3 comma 1, and what we would like to write on this, LCD dot print distance underscore inches, and we also would like to write in for inches in front of this value we have received from the eco pin. Okay, this is of after the formulation. From the eco pin we will receive this value, which is duration. Okay, let's give it some delay of maybe 2 seconds, and then we can also print the duration, the value that we have received from the eco pin. We can also write something on the serial monitor. So I will show it to you once I connect the hardware. We can also, this will be some very rough value. We can also write the value of distance underscore centimeter on our serial monitor. So I have written serial print ln. Ln basically means next line. Okay, now every time this our Arduino sends the value to the serial monitor, it will be written on the next line. If it is not written on the next line, then it will be jumbled up. It will be a huge sequence of numbers. Okay, now once we are done with this, let me close this body of else, some delay again, a delay of 100 milliseconds, and then each time we would like this LCD to get clear in order to write the next value. Okay, now I feel that there is an extra bracket, so let's verify this. First of all, let's save this. Extra underscore ultrasonic. So I have saved this sketch, And yes, this is giving me some error. It is expecting something. Yeah, this requires one more bracket as well. One for this and one for this overall. Let me verify this again. Yes, this is what I felt before verifying it. I guess this is an extra bracket. Let me verify it again. Okay, so now it is working. We can also check the path where our hex file is saved. I have made a specific folder which is in C drive. Folder is hex file and extra underscore ultrasonic. Okay, now this is what I am going to give to this Arduino. Okay, the path is actually C hex files and this one extra underscore. Okay, now let me run this and see whether this is working or not. Okay, so this is working perfectly fine. Okay, now we can ensure whether this is working fine or not by two ways. One is, if I change the value of the potentiometer, this value should also change. Okay, currently it is 548 and now it is 716. If I decrease this, the value of the potentiometer, this value is going to decrease as well. Okay, so now it is 369 and in inches it is 145. So this is working fine. The second way of checking this value is whether this is accurate or not. For that we have to see it practically. We will have to place an object in front of the ultrasonic sensor, and from a scale we can measure whether this value is accurate or not. So accuracy of this ultrasonic sensor can be improved by placing this ultrasonic sensor practically somewhere. For example, you can make use of this same coding, or it can slightly change depending upon the application where you are using it. You can use this excuse me, ultrasonic sensor to check the water level of your water tank. Okay, so I would like to urge you guys to install this ultrasonic sensor in the in your water tanks in order to see the level of the water every time. You can place this LCD in the kitchen or in your room to see what is the status of the your water tank. And besides this, you can improve this code as well. Once I will also do a lab on Internet of Things. Once we are done with that lab, after that you will be able to see the data or the level of your water tank on your mobile app or on your web app as well. Okay, you can also automate the your water machine. It will turn on after a specific, when the water level reaches a specific level. For example, if 10 centimeter water is remaining in the water tank, the water machine will turn on automatically, and when it reaches 90% of the water tank, it can turn off. So I will do a lab on that as well. We will interface a relay with which you can automate this whole process. You can automate the motor of your water tank. Okay, so in the upcoming labs I will explain that. Okay, so after this, we are done with the simulation of ultrasonic sensor. We just have to do the connections of ultrasonic with the Arduino and connect the LCD and burn the same code, burn the same hex file in our Arduino, and it should work. So I will do the hardware part for you as well. Thank you.